In this lesson, we are going to answer the questions, what is a variable and how we can work with one in C++. A variable is essentially a named container for some piece of information. That is, it is used to store information and has an identifier to address it by. Your interaction with variables in C++ will differ slightly from what you have learned in basic algebra, but the key idea remains the same. They're used to manipulate and retrieve some data. Please note that in C++, each variable has a specific type, an address, and a value. For the time being, we are not going to concern ourselves with the address of a variable, but know that it is located somewhere on the computer's memory. Consider the following equation from algebra. Here, we are assigning the value 123 to the variable named x. If I were to write an expression x plus 2, the result of this expression would be 125. This is because you can simply substitute the value 123 for the variable x. Thus, a variable acts like a named container. In this example, the container stores the value 123 and is labeled as x. In C++, a variable must be defined before it can be used. When defining a variable, you must specify the name of the variable and the type of its value. Optionally, you can specify an initial value for your variable to start with. Please note that a variable in C++ should only be defined once. You need to use the following syntax in C++ to define a variable. First, you need to specify the type, followed by a space, followed by the name of the variable, and ending the statement with a semicolon. As an example, consider a variable count, which can store only integer values. An integer is represented using the word int in C++. So the type of this variable is int. Following the type is a space, followed by the name of the variable, which is count, and the statement ends with a semicolon. Now we have successfully defined a variable count which can store integer values. Optionally, you can specify an initial value for a variable. This is called initialization. Here, simply extend the variable definition syntax by adding an equals to symbol and the value you want to store in the variable. Extending our previous example for the count variable, now we are going to initialize that variable to store the value 5. All we need to do is simply state the type, space, the name of the variable, followed by an equals to symbol and the value 5. We end the statement using a semicolon. Initialization combines the definition and assignment aspects of a variable. In the upper example, we are defining a variable a which can store integers. Then, in the next statement, we assign the value 10 to this variable a. In the bottom example, we define a variable b which can store integers, and in the same statement, we assign the value 10 to the variable b. We condense the upper two statements into a single statement using initialization. While initialization is not required, it is recommended to avoid unpredictable behavior. Now, let's take a look at a few examples for variable definitions and initializations. In this example, we have the type, followed by the space, followed by the name, and followed by an initialization. We end the statement with a semicolon. Thus, this is a correct initialization of the variable cans to the value 6. Now, if I want to update the value of the variable cans to 0, and I write something like this, would that be correct? Turns out, no, this would not be correct. You can only define variables once. Thus, if you specify the type and the same variable name, then this would be considered a redeclaration. Your compiler will give you an error. If you need to update a variable's value, then all you need to do is specify the name of the variable and the value that you want to assign it to. Remember, the equals to symbol is an assignment operator. It takes the value on the right and assigns it to the variable on the left. In this example, notice that the type is specified, the variable total name is specified, and it's initialized to this expression cans plus bottles. Now, this would be a valid expression if and only if the variable cans and bottles are defined themselves. If the variables cans and bottles are not defined, then this would be incorrect. In this example, we can notice an initialization. We have the type of the variable name itself, and the value 10. But notice the 10 is wrapped within the double quotation marks. This is not something we have seen before. In C++, double quotation marks around an entity indicate a string literal. And a string is a fundamental data type in C++, represented by the term string. We will discuss strings in a separate lesson, but for the time being, note that the string 10 is not equal to the integer 10. Thus, here we are trying to assign a non-integer value to an integer variable. This is not acceptable because there's a type mismatch. As a result, this is not a valid initialization. In this example, we are defining the variable named bottles, which is of type int, and we are ending the statement with a semicolon. So this is a valid statement. But can you predict the value of this variable bottles? Turns out you cannot. Whenever you define a variable without initializing it, the variable is assigned an indeterminate value. You cannot predict what that value would be. Thus, it is always safer to initialize your variable to some standard value. In this example, notice that cans and bottles look like two different variable names, but they're only separated by a comma. You can combine variable definitions for multiple variables as long as they're of the same type. Here, we have the int data type, and then the cans variable name, followed by a comma, followed by the bottles variable name, followed by a semicolon. This implies that both cans and bottles are variables of type int. Now, let's take a look at a programming problem. What is the volume of a 6-pack of 12-ounce cans of soda in liters? That is, each pack contains 6 cans and each can contains 12 ounce worth of soda. How can we convert this quantity into liters? The additional information that you may require is that 1 ounce is equal to 0.02957 liters. So this is a pretty straightforward question. The result is this product. Here, we know that each can is worth 12 ounce and each ounce is worth 0.02957 liters. And we have 6 of those cans, so the result is the product of these quantities. But what if we have 8 cans in a pack? Well, the only thing that changes is the first term. It becomes 8 instead of 6. Now, if we extend it further, what if there are n cans in a pack? In that case, the first term would become n, and this is our variable. Let's write this as a program in C++. I'm starting off with a standard C++ program template. First, let's go ahead and print the result for a 6-pack of 12-ounce cans. In order to print the result, we'll need to start by writing cout, then we'll use the stream insertion operators, and then we'll specify the product. And because we want things to appear on a separate line, we're simply going to use an NL. After saving the program, compile it and run it. We get the following result. But what if we want to use a variable instead of a fixed value, 6? So we can simply replace this with a variable n. Go ahead, compile this and execute it. Upon compiling, you get an error which states n was not declared in scope, which hints at the fact that n is not defined. So let's go ahead and define n. Since n is going to be an integer, so we can start with int and then the name of the variable, which is n, and ending the statement with a semicolon. Now let's assign the variable n a value of 6. Let's go ahead, compile the program and execute it. We get the same result as in the previous run. You can also combine the definition and assignment statements into an initialization statement. All you need to do is simply state int n is equal to 6, and you can get rid of the second assignment statement. Compile it and execute it. We get the same result as in the previous runs. Now, you can also modify the value of this variable n to get the result for different n values. And there you go. Now, let's try and get a value of n from the user. First, let's prompt the user to enter the value of n. Next, you'll need to type in cin and the stream extraction operator, and then the variable n in this statement with a semicolon. This will get the user input and transfer that input into n. Let's compile it and execute it. So let's give the value 10 and we get the resultant value. Notice that we initialized our n with 8, but when we get the user input, that n is overridden. That's it. Try this on your own machine and see you in the next one.